on my screen.
So our next speaker and the final one for the day is Dewi. I met Dewi as a master's student at Monash, but on reflection, you've actually graduated now. So my information is a month or two out of date. But I worked with Dewi very closely on an R package, which was looking at multi-level regression with post-stratification, and was just sort of blown away by Dewi's ability to deal with large data sets in a reproducible manner. And Dewi's going to give a talk today about reproducible practice in taming wild data. So thank you very much for joining us.
Thank you, Rohan, for having me. So today I'd like to present my work in taming the wild data and how we build a reproducible workflow in it. And this work is done with my collaborator, which are Dai Cook and Tanaka, Nick Turney, and Kat Hyde. Most of them are from Monash University as well. And then first thing first, I'd like to tell you the motivation of this work. So for teaching and learning in introductory statistics and data science courses, Kim is mentioned in 2018 proposed that the 3R of the ideals data, which are rich, real, and realistic. Rich meaning that the data meaningful enough to answer the questions. And if you build a data analysis with data, then you can draw many insights from it. Real meaning that the data provide the context to the data user, and realistic, which means that the data is not always come with tidy form. It could be messy, and then the pre-processing is often needed. On the other hand, for learning and teaching as well, there is a proposal also that the textbook data or the data has to be a minimum of prerequisite. So the analogy is like this: the wild data, the data in the wild is like the wild animal. It could be messy, it's hard to play with, and then almost always that it satisfies the third R, which is realistic. And the tame data, just like this, they are easy to play with and then has a minimum prerequisite. So if we make that the two views together, it is counterintuitive because the third R need the pre-processing in the data. And then on the other hand, it said that it has to be minimum prerequisite. So we try to create the tame data that are rich, real, enough to answer the question and provide context, but also tidy and clean. So this is the motivation of the work. And in order to tame the wild data, there are several works to do. And based on this data science pipeline, we can see that we have to import the data, we have to tidy it, transform, and all of it. And in a similar manner, the Vandelu and de Jong proposed the statistical value chain, which is more suitable for the context of official statistics. And then there is some works to do from raw data to the valid data, and in order to produce statistics and output. And we can see that data cleaning and data tidying and pre-processing is very important in this process. However, the problem is data preparation is time consuming, and yes, yet it is the least enjoyable task. So this one is the result of the survey that asking data scientists that most of the time spent for data science task is for cleaning and organizing the data and collecting the data set. And when asked the least enjoyable task, most of them answer that the cleaning part and collecting the data sets are the least enjoyable. And the other problem is that these stages, the data cleaning and preparation, are often neglected, disorganized, and decision made during this process is often unreported. So, which means that there is a lack of reproducibility often in these stages. So, but in fact, that reproducibility is very important. And in the case of creating the data that is suitable for teaching or textbook data, the reproducibility is really important to, for example, to refresh the data, to make it more up-to-date, because we need up-to-date data to teach people and to analyze in order to be still relevant to the current context. So that's why we built a reproducible workflow, and this is our work. Yahweh is actually a mythical creature in Australia, but in this case, it stands for the years of wages to investigate and explore. So we create an R package that is contains longitudinal wages dataset and several demographic variables from the National Longitudinal Survey of Youth, or NLSY 79. And then the period covered in this data is from 79 until the most recent survey published, which is 2018. And the aim is to provide longitudinal dataset that is suitable for teaching statistics, especially longitudinal data analysis, and with reproducibility and transparency emphasized. So this package has 3 data sets in it, which are the demographic data, the longitudinal wages data of the complete cohort, and then the third one is the wages data of high school dropouts. This is actually the refreshed version of Singer and Willet's data in their textbook longitudinal data analysis. So this book contains the wages data only until 94, and then we try to refresh the data until the most recent year of the survey. So why we choose this data set? It is because the NLSY 79 is quite an important survey. It has been used in research in various disciplines such as public health, economy, education. And this survey is carefully designed with high retention rates, so it's suitable for a life core research. And also this data set has been widely used in textbook, including in Singer and Willet. And this data also used as example data in our package Burger. So that's why we try to refresh the data. And the variables included in the original data, which the original data means here is the data in the Singer and Willet. And it covers variables of the ID of the data, the wages itself, the work experience of the individual, the graduate equivalency degree status, the highest grade completed, and then the dummy variable where the ID belongs to the Black or Hispanic group, and also the unemployment rate in the corresponding year. And in the refresh data, we try to create a similar variable as in the original data, but we add some variables to enrich in which we believe that will enrich the downstream analysis from data. And also to improve transparency, we also include other variables, such as a binary variable, whether as the implication of the data pre-processing with it. So, for example, whether the observation in that, whether the wages in that observation is imputed or not. So that is the plan. And I will talk about how do we get the data. So the data is publicly available in here. So getting the data is quite straightforward. We can upload a text set. So if we previously have downloaded the data, we will have a text set of all of the variables in their own name. We can just upload it, and then they will automatically generate the variables, and then we can download it again until the latest data available in this website. But if we haven't had downloaded before, we can search the variable, select it, and then download the data. So it is quite straightforward. And what I like about it, so this is the text set. So there is a tag of variable name in its raw data, and then we can upload it again in the future. So it is really good for starting the reproducible workflow, because they already make us all of the raw variable names for us. But in this case, the bad news is because we want to refresh the data, the old data, some variables in the original data are not explicitly available in the database. So it is needed a detective work in order to recreate the variables, because not all these variables is also explicitly articulated on how we calculated it, on how they calculated it. So, and I will talk more about it in the next few slides. And yeah, of course, the downloaded data is not tidy, and then it is the reality that the data in the wild almost always is not tidy. So we tidy the data, and which I by not tidy, I mean is the data contains so many variables. They put the data in the wider form, so we have to make it in the longer form, rename the variables, separate the variables and the year and the corresponding survey year, and mostly done with tidy first to rename, pivot longer the variables, and change the data type with the appropriate data type. And also the final data, we save it in the table, which is, it is a class of data frame that is suitable for temporal data, in this case, longitudinal data. So as I mentioned before, that not all the variables in the textbook is explicitly available in the database. So we have to recreate it. And one of them is experience. So Singer and Willet use experience as the time index. So we can say that it is one of the most important variables in the data set, because it formed the longitudinal structure of the data. And however, this variable is not explicitly available in the database. So there is no single variable in the NLSY investigator mentioned about experience. So which means that this must be a calculated variable. And the other problem is there is no code or explicit explanation available in the book on how it is calculated from the raw data. And the only explanation is available is that the experience is the length of time measured in years since entering the labor force, with T0 is the first day of the subject starting to work. And after we search this variable, we found that there is one variable in the database that is actually similar to this. And this is the variable name is the original dates of starting to work. So we thought that, oh, maybe this variable is the variable that they're referring to. So we try to calculate the experience from this, and we compare it. And we couldn't do a directly comparison, for example, making the scatter plot between the experience in the refresh data and then the experience of the original data, because we only have the ID. But in order to join the longitudinal data, we also have to have the years or the time variable. And then in the refresh data, we only have years. And in the original data, they didn't publish the year of survey. It's only the experience. But we actually searching for experience, so we cannot do that directly. So we just have to match, have a spirit plot to actually match the pattern. And as we see that it didn't quite match. So we try again, and then we continue the detective work. We from the topical guide of the NLSY 79 data, we find that there is a topical guide of work experience, and then this is a list of variables that is actually related to the work experience. And then so we take one of the variable here, which is the number of weeks work since the last interview. And then we finally use this variable to calculate the experience. And it is not exactly a match, but the pattern is the same. So we finally just using it. And lesson learned that it's really important. If we create a data set from the wild, should be ideally come with the documentation and how they are calculated. And also the other problem is there are many anomalies of wages data that in the raw data. So we create the summary plot of the data set. It's the summary of wages of each individual. We can see that there is implausible value here because it's quite not makes sense that one person having almost $60,000 an hour in their wage. And so we try to randomly get one ID, and we see here like it's quite suspicious because this this respondent only have one period of time that having a really high wages, and another years they just have this kind of wages. So further we sample the data, we can see that some people, some observation has variability in it, some observation only participated in a few years of the survey, and then we can see that it is possibly error as well, because they only experience once on their the high wage. So we try to treat the anomalies. We use, it's not the fanciest method. We using the robust linear model with wage and year as response and predictor respectively. And because this one is the longitudinal data and every person has a different pattern of their wages. So we built the model for each individual using the nest and function from tidy R and poor. And each observation from this model, each observation will have weight, and then this weight is used to create a threshold to decide whether the observation is anomalous or not. And then we decide the threshold is 0.12. This is come from several simulation that this weight is can treat the anomalies, can eliminate the extreme values, but also still maintain the variability of the data. And it is related to the real characteristic, because it is the real world case that the wages is not always going up, but it could be up and down. So we are not trying to make the wages as smooth as possible, but we just want to try to treat the extreme values like I showed before. And then here is the result. We can see that some people still having the variability. We can see that the dashed line is here is the before, and then we can see the after they are already taking down. So we impute the extreme values with its predicted values from the model. And so because we refresh the data, so we compare the data with the Singer and Willet with the original data, but then we have a problem again, because in the textbook used the dropout subset, right? And then, but they didn't mention any definition of how they subset, how they filter the data from the complete cohort. They just said that the dropout data of male age between 14 and 17 when the first survey conducted. So we try to filter the data, which this case, and dropouts variable is also not available in the database explicitly. So it must be derived also from other variables. So we try to use the GED information and also the highest grade completed to actually recreate the subset. It's not exactly the same because again, there is no formal documentation about it. And we can see that this one is the comparison between the original and refreshed data in terms of the data of the highest grade completed. We can see that it's not match. It's not that match in every highest grade because in the refreshed data we only have smaller proportion of people who have completed 10th grade. But here's there are more people who completed 10th grade in the original data. We can also see this one is the experience that we recalculated, which I mentioned before. We can see that the pattern is quite matched. It's not exactly matched, but we try our best to have the closest result. And then in this one, it is quite different because in the original data, they adjust the wages with the inflation rate in 1990. And then in here, we didn't do that because we think that adjusting the inflation rate in 1990 might be out of date in the current context. So we will allow the user to decide whether they want to adjust the wages in a certain year, base year. So the reproducible aspects in Yawi, we made all of the cleaning and pre-processing codes and the variable text file available in our GitHub repositories. And also in the vignette, we also create the stages of how we pre-process the data. So it's not only in the raw data that we include the pre-processing file, but we also make it in the vignette of the package itself. It's not updated yet, unfortunately. And then we hope that it can be used as a data cleaning example, just like Rohan said several weeks ago, I think, whether there is a data cleaning appendix ideally with our stats code. So we hope that this data set, the vignette of this data set could be used for that purpose. We also create a Shiny app. So as I mentioned before, that the way that we decide 0.12 might be arbitrary. Some people might not agree with it. So we create a Shiny app actually to customize the threshold. It is actually can also be used in teaching purpose. For example, in weight regression in the RLM, how the weight change the pattern in the data. So for example, here we set the weight, for example, 0.4, and then it will change the data, the summary statistic, it's the before, and there are the percentage of the imputed observation, and we can click here to sample to see before original data and before. So before and after it is imputed. So we create this one, and then next plan is we want to add the function to do inflation adjustment. And we want to, because currently it is only on R, some people might not use R, so we want to put in CSV format and create the metadata and place it in place like Zenodo. So the takeaways from this case study is that the documentation is really essential to ensure reproducibility. Several difficulties encountered in the absence of the code and documentation in the textbook data. We have difficulty in deciding the variables to be downloaded. We have difficulty to recalculate the experience, subsetting the high school dropouts, and matching the original and the refreshed data sets. So, and also because the data has some extreme values, so maybe for the data provider, in this case is the NLSY or the BLS, the Bureau of Labor census. So it's we recommend a better validation rule to be applied for the data providers in the data entry stage, so that maybe if the anomalies like the extreme values could be eliminated before it is published. And that's all. Thank you very much.
Thanks, Dewi. That was amazing. Are there any questions or comments that folks have? I'll just get started. How long did this all take you? What was the sort of development timeframe?
Sorry?
How long did this all sort of take? What was the time frame over which this was all put together?
Actually, we made it in the summer last year. We made this package, and maybe 2-3 months, but we actually submitted in a paper, and then we have to revise. So maybe it's 1 year, including the revision of the paper that we submit.
It's very quick, far quicker than I was expecting. Are there any other comments or questions?
Yeah, nice talk. I took a quick look at the Yowie package, and most of the documentation is about the data itself. Is the package include the code to like clean from the raw data?
Yeah, it is.
I just had just a brief look. I had trouble figuring out where that code was, but it looks very, very neat. Thank you very much.
Thank you. So we actually have, I will share my screen. So we have the data documentation here. So this is the text set that I mentioned before. So if someone want to reproduce the data with the recent survey published, then we can just upload this text set in this website. And then we also have the data preprocessing here with all of the code, with all of the original variable names. And then this one is to make, to actually preprocess the high school dropout, and then the possible, this is the comparison between the single and data and the data we've created or we refreshed. So we make all of the code available, and also in the vignette, it's not updated yet, but we upload the vignette in its website. So we have the articles here, steps to process the raw to the input data, and then until the failed data. So it's pretty much like that.
Oh, that's wonderful. Thank you very much, Dewi. Really appreciate the presentation.
Thank you. Thank you for having me.
Oh, of course. And so that brings Thursday to an end. Dewi's Friday is just starting. You're in Indonesia at the moment, aren't you?
Yeah, it's 5 a.m. here.
Oh my gosh, right. So your day is very much just starting. We appreciate you getting up early. It's 5:30 p.m. here. So
yeah, thank you.
Yeah, so thanks everyone, and hopefully see you tomorrow. So bye everyone, have a nice evening.
Bye.
Bye, Dewi.